Unit 1, Atomic Theory. Today what we're going to talk about is the history of the atomic theory model, starting with the earliest scientists all the way to the most recent research that we have. The word atom actually comes from a word called atomos, which means not to be cut, and that actually was developed back in the early years with Democritus. Here you'll see that we have an atomic model. This is very familiar to what you may have already seen before. This is the general idea of what we think an atom looks like. It has changed a lot. We have always known it was kind of like a ball shape, and this belief started back in the 400 BC with a scientist. Well, here's a list of all the scientists. The first one we're going to talk about is Democritus. He was a Greek philosopher who actually figured out coming up with this. And he pretty much started asking, could matter be divided forever? Could it be that we never reach the end? And he was thought to be crazy because he thought that way. His whole theory was that matter could not be divided into smaller and smaller pieces forever. That eventually we would reach the smallest possible piece. And that piece would be indivisible. And that's why he named it atomos. He just thought it was a ball shape. To him, they were very small, they were different shapes, but they were all made out and they were infinite, which means unending. And they could join, so he was actually on the right track. Back in ancient Greece, that was not a good thing to think like that. It was actually ignored for more than 2,000 years. Prior to that, they pretty much thought that the elements were everything was made out of either air, water, fire, or earth. So when Democritus came up with this, he was thought to really be a crazy guy. So this is kind of where we're going to look. We've started talking about Democritus, and we're going to work all the way to the wave model. So the first guy we need to talk about is an English chemist by the name of John Dalton. He is considered the father of the atomic theory. He started us on this big quest. Notice it's in the 1800s. What he decided was that there were 4 parts to his theory. That all elements were composed of atoms, and that they were indivisible and indestructible. 2 atoms of the same element look exactly the same. Which means if I saw an atom of oxygen here, and I travel to Africa and I find another atom of oxygen there, it should look the same. Vice versa, atoms of different elements look different. And then that we could form compounds by taking these atoms of 2 or more elements and combining them together. He was almost correct. That whole theory became our foundation for what we study today. The next scientist we need to talk about is J.J. Thomson. He did something called the plum pudding model. Strange name. Think about chocolate chip cookie dough. That might be an easier way to remember. He said that he thought the atom was made out of even smaller particles. And that's why it was called the plum pudding. This is what plum pudding looks like. He actually started coming up with ways that he figured out that the atoms were actually positively charged, and that when it came near some negative charges, those negative charges went flying everywhere. Okay? And this is what his experiment actually looked like. He studied electricity going through a gas. And he said that as the current was going through that gas, it gave off negative charges. We'll get into that later. And that was surprising because he thought the atoms were uncharged. So where did this charge come from? Well, what he said was that the atom was divisible, and he came up with this thing called a corpuscle. Now we name it the electron. A few years later, we get into Ernest Rutherford, another English physicist at the turn of the century, who really started looking at a lot of the other parts to the atom. His experiment was called the gold foil method. And what he basically did was fire some particles at these atoms in the gold foil and watch what happened. And what he noticed was that a positive is going to repel